So today, of even more importance than yesterday, is drawing a picture, because there's two things that we need to account for. We need to account for capital R and lowercase r. One is the axis of revolution that's an outer bound. One is the axis of revolution that is an inner bound. They're both top and bottom. They're both top minus bottom. But they're separate. They're different. So especially with these, with all volume and area, I would always start with a picture. So whether you're drawing a picture, like x squared plus 1 is just a parabola. Y equals 2, x-axis, those are all not hard functions. But if you want to use your calculator, it'd be good practice. So what I want you to do is get a picture of what these will look like and draw it. First thing we're going to do is get a picture. Use your calculator if you want. That's totally okay. But get a picture of what we're looking at here. Oops. So y equals x squared plus 1 is one of them. Y equals 2 is another. And then the x-axis. The x-axis is y equals 0. Okay. So then transfer that, whatever picture you see, transfer it as best you can to your paper so you know what you're looking at. Okay. We're looking at the area. So the part we're looking at is the enclosed area. The enclosed area. I should probably get a better picture. Okay. So take a little time to draw a good picture. Your picture should look like that. The x-axis is down here. So this one is going to revolve around the x-axis. So if it revolves around a horizontal line, it's a horizontal revolution. Okay, so that means it's going to be dx. Horizontal revolution. It means it's dx. If it's revolving around a horizontal line, it's a horizontal revolution. If it's revolving around a vertical line, it's a vertical revolution. That's how you know which one, if it's dx or dy. Okay? Okay, so this is the yellow part is the region that's going to be revolved. So the yellow part, again, it's kind of hard to see. It's kind of hard to see because it's spatial. Some people can see this. It's so kind of visualization, spatial reasoning, spatial kind of thing. It's one of the hardest things to do. A lot of times it's one of the last things to develop in the brain. So sometimes you can't see it, sometimes you can see it. Doesn't mean if you can't imagine it, it doesn't mean there's anything wrong with you. It just means that part hasn't developed in your brain. It's one of the last things in the brain to develop. So what's going to happen is this yellow part here is going to come out and it's going to revolve around the black line. It's going to come out and revolve around the black line. So it's going to kind of make a donut. It's going to make a donut, and this part's going to be the hole. So it'll come out and go around. Okay, so it's going to kind of make a donut kind of shape, a donut with like a flat edge. Okay, so again, being able to see the object is not important. Being able to find the volume of it is what we're doing here. So we have this yellow thing. Okay, so we saw in our notes, big R. Big R is the axis of revolution. It goes from the outer boundary. Okay, the outer boundary is from the top of the shaded part to the axis of revolution. That's the outer. So let's go look at ours. Okay, so the top of the yellow is the blue line, right? So let me pick another color. So from here to the axis of revolution, I'm going to draw a straight line. To here. That's capital R. Okay. So let's go to our equation. So capital R goes from the blue to the black. The blue is y equals 2. The black is y equals 0. So it would just be 2 minus 0. That's capital R. Goes from the top of the shaded part to the axis of revolution. That's how far it extends. The inner goes from the bottom of the yellow, so the stuff holding in the bottom. That's the parabola, right? The parabola is holding in the yellow on the bottom, right? And extends to the axis of symmetry, or not the axis of revolution. That's little r. Okay. So that one, the red is y equals x squared plus 1, right? Minus the black, which is y equals 0. So x squared plus 1 minus 0. Okay. Now the bounds. The bounds are from left to right. Since this is dx, the bounds are always from left to right. So the bounds, I'll highlight in pink, are from here to here, right? You can check those in your notes. You can check those in your calculator, right? But I'm pretty sure it's -1, 2. Pretty sure these guys are -1, 2, and +1, 2. Right, where the blue and the red meet. So since it's dx, we only want the x. So from -1 to +1. Before I put it in my calculator, I'm going to clean it up a little bit. 2 minus 0 is just 0. Or sorry, 2 minus 0 is 2. Squared is 4. Minus x squared plus 1 minus 0 is just x squared plus 1. Now, calculator. Plug that into your calculator. See what you get as the volume. Oh, don't forget the pi in the front. Okay. Oops, what did I do? Oh, I forgot to put the squared. Forgot to put the squared over this part. Yep. Parentheses should be squared. 4 doesn't have to be squared since we already squared 4, but the parentheses need to be squared. So we get 13.404. 13.404. Done. Okay. Number 2 is almost the identical. The only difference is it's revolving around a different line now. It's revolving around y equals -1. So everything's the same except where it revolves around. Well, y equals -1 is still a horizontal line. So it's still a horizontal revolution. Okay. So it's almost going to be identical. The only difference is the black line is going to be moved down 1. That's the only difference between the picture that you have for 1 and 2. So there we go. So the axis of revolution is now green on mine. Okay. So the area is still the same. The bounded region is still the same. The only difference is the axis of revolution moved down 1. Okay, so now big R, capital R goes from the top of the shaded to the axis of revolution. Okay, so the top of the shaded is still the blue. The axis of revolution's gone down 1. So the blue is still y equals 2. The green is y equals -1, and then the red is y equals x squared plus 1. So it's going to be 2 minus -1. 2 minus -1, which is 3. Okay. That's little r, or that's big R. Little r is going to extend from the bottom of the yellow, which is the red. The red is holding in the bottom of the yellow, to the axis of revolution. So that's going to be x squared plus 1 minus a negative 1. Okay. Bounds. Bounds are the same, right? Bounds are going to be the same because the yellow part was exactly the same. -1 to +1. So before I put it into the calculator, I clean it up a little bit. 2 plus 1 is 3. 3 squared is 9. Minus. And then this is going to be x squared plus 2 now, squared. And when you do that, you should get 21.782. Verify that, and then we'll go. Hey, Leon. Thanks. Uh-huh. Let's jump a little bit to number 5, because number 5 is the same picture, but a different revolution. Okay? So number 5. Let's jump to number 5. Since number 5 is, the first two are exactly the same, it just revolves around a different, right? Okay, so it revolves around x equals 7 now. X equals 7 is a vertical line. So this one's going to be a vertical revolution, which means dy. Okay, this is going to be a dy guy. Picture is going to look almost identical, right? The only difference is it's going to be x equals 7. So it's going to be, so it's going to be revolving this way, right? So let me draw a picture here. So it's the same picture you guys have been drawing. The only difference is the axis of revolution is not below it, it is to the right of it. So we got 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 1, 2. So it's the same graph you guys just did, the same parabola that you guys just created. Y equals 2, which is right here. The only difference is there's a third line or a third graph, and that one's x equals 7. I didn't do this one in the calculator because the calculator can't do x. Wait, I think it can do x equals 7. I think it can. Okay. 1, 2, 3, 4, 5, 6, 7. Yeah. No,
I don't think it has like an x equals something.
Yeah.
It has the x equals root.
Yeah, so you can do
So just
a line, right?
Deleted.
This one right here?
Yeah.
The inverse. So you just hit, so you just hit that and then delete the square root and then put, yep, that works. Okay. Okay. So again, the bounded part is still the same. Y equals x squared plus 1 is there. Y equals 2, x equals 7. Okay, there's our graph. Oops. Volume equals pi. Capital R minus lowercase r. This one is dy. Okay. All right, so let's go to the front, or sorry, the beginning, and it says, I didn't put that. Why didn't I put that? So for dy, for dy, I should have put dy in here too. It's going to be right minus left. Right minus left. So for dy, let's include that here. For dy. Okay, so for dy, it's right minus left, kind of like yesterday. Right minus left. So we're going to start from the right and go to the left. Okay, so when we go to the right, well, the thing that's most right is the axis of revolution, right? So we're going to start there. Okay. And then we're going to extend into the yellow until I reach the end of the yellow. Okay. So watch before you do. So I keep going, I keep going, I keep going. I go in the yellow and I stop when I exit the yellow. So right there. That's going to be capital R. So capital R goes from 7 to x squared minus plus 1. But the problem is I can't put x's in my dy. So I have to solve y equals x squared plus 1. I have to solve that for x equals first before I put it into my equation. Oops, not y squared. X squared plus 1. So I'm going to subtract 1 from both sides. Then I take the square root of both sides. So it's plus or minus, right? Which one do I want? Do I want the plus or do I want the minus? So we're talking about y's right now, right? So here's the thing. We're talking about y's. So are the y's positive over here or are they negative over here? Where I'm at right now. Positive, right? So I'm going to want the positive version of it. Yep. Because at that point there, I'm going to want the positive because the y's are positive, right? Or wait, no. Wait, over here, the x is negative. Let me look at my notes real quick. 1 equals 2 minus. Okay, so on this side, because it says x equals, Yes. Because it says x equals, on this side over here, are x negatives. Negative x's are negatives, right? So I want the -1 for this one. So this one, I'm going to want the negative version of that. Because, yeah, and on the other side, when I do little r, the x is going to be positive, or it's going to be the positive version of it. Okay? Okay, so it's going to be 7, 7's the right, minus negative root y minus 1. Because on this side, the x's are negative. On this side of the y-axis, the x's are positive. This dot, this yellow or orange dot, extends to the left side of the y-axis. That's where x is negative. Okay. Okay. Now let's do little r. Little r starts in the same spot. It also goes from left to right. Except it stops when it hits yellow. When it hits yellow, it stops. It doesn't go into the yellow. It stops when it hits yellow. Now you're saying, like, what's the difference? Don't they hit the same graph? One hits the positive version, one hits the negative version. Capital R hits the negative version because it goes across the y-axis where the x's are negative. Little r doesn't make it across the y-axis. It stops before the y-axis where the x's are positive. So it's going to be 7 minus the positive version. Okay. Now the bounds. Okay, so the bounds don't go from left to right of the yellow. They go from the top to the bottom of the yellow. So the top is y equals 2. So 2. The bottom is y equals 1. 1. So 2 to 1. Okay. Calculator? When you do that, you should get 58.643. Double check that that's what you get. I want you to do number 3. Go back to number 3 and do that one. Use your calculator to draw a picture of number 3. Use your calculator to come up with a picture, draw a picture, find big R, find little r, find the bounds, plug them in. So since this is a dx, it's going to be top minus bottom. So we're going to start at the top of the shaded part. That's going to be the red on mine. And it's going to extend down to the axis of revolution. That is big R. Big R goes from the red is e to the x, minus the green, -4, y equals -4. So it's going to be e to the x minus a -4. Little r. Little r goes from the bottom of the shaded. The bottom of the shaded. The bottom of the shaded is the blue. To the axis of revolution. That one's going to go from -2 to -4. So -2 minus a -4. The bounds are left to right. So it looks like from the orange line to the pink line, so that's going to be 0 to 2. When you do that, you should get about 300. You should get around 302.164. Okay. Okay, so let's see here. I want to do one more today. Let's go to 6B. 6B. It's the last problem B, part B, 6B. Okay, 6, obviously B goes with A. So they tell you that the graph, how the graph is made is by y equals x squared, 2x squared, y equals 0, and x equals 2. Okay, so so the parabola is y equals 2x squared. The vertical line is x equals 2. And then y equals 0 is the y-axis. Y equals 0. Oops, not, yeah, the y-axis. Yep. Okay. This one is going to revolve, this shaded area is going to revolve around the y-axis. The y-axis means a y-axis is a vertical line. So it's a vertical revolution. Okay, so that means dy. So that means we're going to have volume equals pi big R minus little r squared dy. So we go from right to left. So right is the very right of the shaded part. The very right of the shaded part, which is x equals 2. And then we're going to go left until we hit the axis of revolution. Well, they said the axis of revolution is the y-axis. The y-axis is x equals 0. So it's going to be 2 minus 0. That's capital R. Now lowercase r starts on the left side of the shaded part. And it goes to the axis of revolution. So that one goes from y equals 2x squared to x equals 0. So we know the 0 part. We just can't put 2x squared in there because it's got to be, can't have any x's, can only have y's. So 2x squared. We have to solve for y, or sorry, for x. So divide by 2 to get 1/2 y equals x squared. Square root. I get x equals plus or minus 1/2 y. So for little r, am I going to use the positive version or am I going to use the negative version? Positive, because I'm on the little r is only on the positive side of the x, of the y-axis. So it's going to be positive square root 1/2 y. Where are the bounds of the shaded part from top to bottom? The bottom is 0. Where is the top of the shaded part? 8. It's where x equals 2 and y equals 2x squared intersect. It looks like 8. If we're not sure, we could always just solve for it, but it looks like it's at 8. Okay. So that's another vertical revolution. Okay. So when you plug that into your calculator, you should get around 50.265.